All right, hi guys. We're going to do the check your understanding on page 328. Okay. For each chance process below, determine whether the events are independent. Justify your answer. Okay, you shuffle a standard deck of cards, you turn over the top card, and then you put it back in the deck, shuffle again, and turn over the top card again. So the first event A is that the first card is heart, and the event B is that the second card is a heart. Okay, are these events independent? Absolutely. When you are shuffling a deck of cards and you take one out, as long as you replace the card that you took out, the second draw is completely independent of the first draw. Cards don't remember anything, okay? And it's not like your probability of drawing a heart is going to change from first draw to second draw if you're putting the cards back. You're still going to have 52 cards, and a quarter of them are going to be hearts, okay? So the number one is definitely they're independent. All right, number 2, shuffle a standard deck of cards and turn over the top 2 cards one at a time. And again, your events are the first card is a heart and the second card is a heart. Well, if you turn over 2 cards at one time, the chance of the first card being a heart, the probability of the first card being a heart, is going to be different than the second card being a heart. Because if the first card is a heart, your probability of the second card being a heart is going to be different because there's one less heart in the deck. So these are dependent. These are not independent. So that draw of that second card does depend on what the first card drawn is. Because if it's a heart, probability is going to change for the second card being a heart. Okay? All right, number 3 says, the 28 students in Mr. Tabor's AP Stats class completed a brief survey. One of the questions asked whether each student was right or left-handed. The two-way table summarized the class data. Choose a student from class at random, and the events of interest are female and right-handed. So are they independent? Okay, so we're going to look up the chance of probability of being a female and the probability of being right-handed. Those are the, oh goodness, whatever, she's fine. Here, kitty, throw it on the floor and let her play with it. Okay. So I went ahead and I come up to the table. I did my totals. I'm not going to write the book. I'm going to do my totals. Okay. Oh my gosh. The cat's going to make noise. Who cares? Okay, so how you can prove that 2 items are independent, okay, come on down to my paper, is you got to use conditional probability. So if the probability of being female, given that you're right-handed, equals the probability of being female, then they are independent. Okay? And if you think about this mathematically, okay, the probability of a person being female, given that they're right-handed, would be the probability that they're female and right-handed divided by the probability that they're right-handed. Now, if they were independent, the probability of female and right-handed would be the probability of female times the probability of being right-handed. And if you divide that by the probability of being right-handed, of course you're going to be left with the probability of being female, which means probability of being female is independent of whether you're right-handed or not. Okay, so if these all happen to equal, if these equal, okay, then you know they're independent. Okay, so this part we're going to get from the table. We're not actually going to multiply them. So if we look at the table, probability of being female and right-handed, come up here. Female and right-handed is 18, right? So let me put that down here. Over the probability of being right-handed. So that's over 24. All right? Is everybody with me? Okay. So is that the same probability of being female? Come back up to the table. So the probability of being female is 21 over 28. Okay, stick those in the calculator. Let's see, 18 over 24 is 0.75, and 21 over 28 is also 0.75. So they are equal. So since the probabilities are equal, then being female and right-handed are independent events. Okay, if they weren't equal, they would be dependent on each other, but apparently they're not. Okay, it works both ways. I could have switched this. I could have done the probability of being right-handed given that you're female, and if that's equal to the probability of being right-handed, they should be independent. Now, it should work because the events, we've already proved they're independent. So if I go through this process, probability of right-handed and female given or over the probability of being female should equal the probability of being right-handed. Well, we already have this. This is the same thing. Female and right-handed is the same thing. So I'm going to put 18 over. What's the probability of being female again?
1/2.
Wait, what is
Right.
it? probability of being female is 21. Okay, so of the females, come back up here to the table. So of the females, 21, 18 are right-handed. Okay, so remember that's another way you can look at conditional, like we did in the first chapter or whatever it was. Okay, let's compare that to the probability of being right-handed. Come back up. Probability of being right-handed is 24 over 28.
Do they really have to put this much work for one question?
Yes.
Oh my God.
So 18 over 21, throw that in the calculator, is 0.85. 7 and 24 over 28 is the same thing. So again, we've proved both ways that the probability of that the events being female and being right-handed are independent. Okay, thanks. Bye.
You gonna sign off?
Yes, goodbye.